This task assumes prior knowledge of the game rock, paper, scissors, where two players face off each other, and on the count of three they choose either rock, paper or scissors at random, and it's kind of luck of the draw whether their choice dominates the other player's choice. So for example, rock dominates scissors by damaging them, bending them, paper dominates rock by wrapping around it, and scissors dominates paper by cutting it. So in this task, there's two parts. First of all, we have to build a function that will randomly give us back one of those three strings shown here in capital letters. And then secondly, we have to develop this into a proper game where we see a kind of a best of three being played out. So let's begin with step one, which is to build a function which will allow us to select one of these three at random. In order to do this, I'm going to import the random feature of the Python language, and I'm going to define a function called getChoice. There isn't going to be any parameter required here. We're just going to allow the function to generate one of the three strings at random. So what we can do here is build a list of all three of our options. In order to do that, I can do double quotes, double quotes, double quotes, and then I can go and take copies of each of the words shown in uppercase. Rock dominates scissors, scissors dominates paper, so put them in that order, then paper dominates rock. Okay, so next we're going to use the random feature of our program, and whenever we do this, we're going to say random dot, and then it has a built-in feature called randrange, a function called randrange. You can see here it's telling us what to do. We choose a start number and we choose a stop number. Those are the only things we really have to do. You can see that the step is optional. That's why it's enclosed in square brackets in the tips here. So we're just going to say we're going to choose a number that's in the range 0, 1 or 2. Therefore our starting value is 0 inclusive, but we're never going to arrive at the number 3, so it excludes the number 3. In this case then, what we want it to do is we want it to generate that random number, and then we want to visit the list of options at that randomly chosen number. So we use the square brackets, and what we find inside the square brackets is of course the array index, or the list index in this case. Having identified one of those strings, we just want it to return it, and that completes the function. So we have a function that is capable of randomly choosing one string. Okay. Next, we have to build the game itself. Okay, this is going to represent the main body of the program. And now that we've defined our function, part of the awkward logic of the program has now been dealt with. We should begin by just running a few quick tests on the getChoice function to make sure that if there are any bugs, that we can tackle them now. In order to test this better, let's make multiple copies of this just by copying and pasting. And then, if we click run module, yeah, that's it. So it's given us random choices each time, and let's just test it again. If I say run module, okay. With so few to choose from, we see that it's doing scissors and paper and rock. Here, it's just a fluke that it hasn't chosen rock. Let's try it again. Okay, so you can see there, it is very random. With only 3 values to choose from, it's not giving us a great spread of results in the space of 6 or 7 tests, but I'm confident that we haven't introduced any strange bugs. So I'll just take that out at this point. Next, we have to start coding the logic of the game itself. So let's first of all set up a scoring system. So we've got player 1's score, and we'll set it equal to 0. And we can also set up player 2's score and P2's score and set that equal to 0 as well. So throughout this game, it's going to continuously allow the 2 players to make their random choices using the function above, and then one of the 2 players is going to end up having their score increased. So this game is going to keep going until they have played up to 3 points. So we're going to say that while player 1's score plus player 2's score is still below 3, you're going to keep going playing the game. Next, we have to do the decision making. So let's say that we have player 1's choice. So player 1 goes and makes a random selection from the given list of options, and then player 2 does the same. We can just do a simple copy paste there. So they've made their choice, but now we have to try to determine who was the winner. So this is somewhat complicated at the minute because we've got our 3 options listed in sort of an order of precedence. Rock comes before scissors, scissors comes before paper, but also paper comes before rock. So we would have to start thinking about wrapping around inside this data structure. To make things a little bit more convenient here, what we can do is just before we enter the while loop, we can make a new local variable. Let's call it, we'll just call it choices. So what we can do here is we can take a copy of rock and we can add it on at the end. So it is a different data structure than the options list that we had earlier. So this time it means that rock is dominant of scissors, scissors is dominant of paper, paper is dominant of rock. This means that if we find a pair in this order and player 1 has chosen this one and player 2 has chosen this one, then that means that player 1 has won. You could say the same thing here. If player 1 has chosen on the left, player 2 has chosen on the right, then player 1 has won that round. And same thing again here. If player 1's selection is on the left, player 2's is on the right, then that means that player 1 has won. If the order is switched over, then that means that player 2 takes the point. Thirdly, there is the possibility that there could be a draw. So we have 3 possibilities here of what could happen. So let's start trying to code this to see what happens. So if, let's say, so we want to know if player 1's choice and player 2's choice is a pair that's found within this list. So one way we can do this is to build that pair, and actually we could do it in advance. We could say pair equals, and we could say player 1 choice, comma, player 2 choice, like that. And then we can say if pair is exactly equal to, and then we take our choices list and we slice out just the first 2 by saying start at index 0 and go to 2. Okay. Or, and then we do the whole thing all over again. Or if the pair of player 1 and player 2's choices is actually the same as, and we'll do 1, 3 this time, which would isolate scissors and paper. Or, third possibility, and we can take away the word or in this one, put a semicolon in instead. Or, if it starts at this one and just goes all the way to the end of the list, we don't really need a number there, so I'll take that out. We could write the number 4 if we wanted to, we can just leave it out because it's the last one. So if the pair of values is found as either 0, 1, or else 1, 2, or else 2, 3 inside our list of choices, then that means that player 1 has chosen the one which sits on the left, therefore player 1 has chosen the dominant one. That means that player 1's score gets increased. So we take player 1's score and we add 1 to it. Okay, so that increases the score. And then what we'll do is, partly for testing purposes as much as anything else, we'll say player 1 won that round. Okay. We could say by choosing, and then we could get fancy and stick on to the end what player 1's choice was for that round. Okay. Next, we have a second possibility to deal with, which is the eventuality that actually they chose the same thing. So if player 1's choice was exactly equal to player 2's choice, then that means that in that case we are going to have to print a message to say that there was a draw, but the scores are not going to be affected in any way. This was a draw, both players. Then we can change that to say chose. Both players chose, and then we can just show whoever player 1's is fine. And then the final eventuality must be, if it wasn't a draw, then rather than rewriting all of this logic out again, we've dealt with the draw, so we've dealt with player 1, we've dealt with the draw, so that must mean that player 2 won this round. So we can take a copy of all of our code from here and modify it so that player 2's score is the one that gets increased, and then it can say player 2 won that round by choosing, and then whatever player 2's choice was. Okay, so that should, because it's inside a while loop, that should happen 3 times. In the event that there is a draw, neither of the scores will change and the whole thing will be rerun again. Okay, by the end of our best of 3 situation then, one of the players will emerge with the higher score, and that means that we can say if player 1's score is greater than player 2's score, then we can say print player 1 wins, otherwise player 2 wins. It is not possible to have a draw in this entire game unless we get very unlucky and we end up in an infinite loop, because all of the selections that ever emerge are all draws. So let's take a pause here and we'll just put a comment in here to say announce the winner. So let's take a moment just to test this. So we'll say run and run, and then okay, so what has happened? On the first round, player 2 won the round. On the second round, turns out there was a draw, so we proceed and we draw again. This time player 1 was the winner. On the third round, player 2 won, also by choosing rock. And that means that overall player 2 wins. It looks like it's working okay. Let's run it again. Just look for any mysterious problems. Player 1 paper, player 2 rock, player 2 rock, player 2 wins. Seems to be heavy use of rock here, so let's just keep running it. I'm sure it's just a subtle bias, nothing to worry about. Okay, and it gets worse. We'll just move this up. Okay, I'm just going to keep testing a couple more times, just in case there's any strange bugs that we didn't think of. This time scissors emerges much more predominantly than in other times. Sometimes there's a draw. In this case there were no draws. Okay, I think everything's in order. I don't see any real causes for concern. The randomness is creating a bias here. There's very little use of paper throughout the whole thing. But yep, I don't think that there's any subtle biases that have been introduced here. I think it's just it's a random choice at all times. So we're choosing a random number 0, 1 or 2, and it is showing all 3 of them at some point or other during the testing. I'm happy therefore to say that this is a fully working solution to the problem.